Hello again. In the last video we started talking about nuclear fission, and we got to the point where we were talking about the nucleus and how this nuclear reaction physically occurs. So we have a uranium nucleus, and I'll actually say that that's uranium 235, because that's what we use in fission on Earth. And of course, in that nucleus we have protons and we have neutrons. And the protons want to repel each other. They have this electrostatic repulsion for each other, and that's a long range force. So they want to blow this nucleus apart, and they want to do it over long ranges. The neutron holds the nucleus together by the nuclear force or the strong force, but that's very short range. So it doesn't act over large distances. If I fire a neutron, here's our neutron, into that nucleus, I disturb this balance, and also this neutron has some energy, so some of that energy goes into basically causing the nucleus to distort somewhat. And we have, in the textbooks, they say that there's a distortion here. So the nucleus distorts, and also associated with the energy from that neutron, we have increased vibrational energy. So this nucleus becomes even more unstable than it was before, and that then becomes actually starts to elongate, and we have a shape, something like a red blood cell in profile. Now, of course, there's protons in here and there's neutrons in here still. This is the same nucleus, and those protons want to separate from each other. They don't like being near each other. They're all positively charged. But the neutrons want to hold this nucleus together. They have that short-range nuclear force. But of course, by elongating the nucleus, and I'll just state that there, elongated, distorted nucleus, that short-range nuclear force that binds the nucleons together, and in fact binds the protons and the neutrons together, this distance here gets larger. Okay, so that is an increased distance there, and that short-range nuclear force can't act anymore, but that repulsive force, that long-range repulsive force, does, and it blows that nucleus apart, splits it in fact, and that's what fission is. So a splitting of the nucleus, and so we have this plus this. Now this happens in a very short amount of time. Of course, I'm saying it over 5 minutes, but this happens in this long. (10⁻⁻12) seconds. That's a very short amount of time. And we have two daughter nuclei. We'll call these the daughter nuclei. And these happen to be unstable also, unfortunately, and so they're radioactive, and that's part of the problem that we have in Australia with nuclear power, of course. Products generally have mass numbers of 140 and around about 95. And in the last video, I showed how we could have something like krypton and barium given off, unstable isotopes of krypton and barium, and they had, I think the barium had a mass number of 141, and the krypton had a mass number of about 92. So Um, uh, yeah, and unstable isotopes of those, and this is the byproduct of this fission reaction that people don't like. The next video we'll be talking about, or we'll go on to chain reactions and what's going on inside a nuclear reactor. Thanks for watching.